So let's look at geometric mean in this episode of Mrs. M's Math to the Masses. We see a triangle representation, but I want to start with a proportion at the top where you see A and B are two very different values, but the middle terms will match. So A and B are considered the extremes as they are the first and last number in the proportion, and the means are the numbers that match in the center. We will work some examples where we're just given numbers. But I also want you to see an example where you see an altitude on a right triangle. It comes from a vertex to the side across. That's what this segment here has done. And it's perpendicular to the side across. It uniquely forms three right triangles. So the largest one you can see right here, the middle-sized one here, and the smallest one here. And that's what the bottom of the page is showing you. And uniquely, that altitude created three triangles that are all proportional, as we've studied in other units. So this triangle here came down here. The original large triangle flips like this. And the middle size was here, and now it's here. And you have proportional relationships of all the sides. So here are some examples. If we're given 3 and 5, we would write our proportion like we've learned to do, an equal sign between two fractions. We'd insert the two numbers we're given as the first and the last and put a variable that will be the same for the other two positions. We would cross multiply and solve. So for this problem, x times x would be x squared. 3 times 5 is 15. The opposite of a square is a square root, and x would equal the square root of 15. We'd be done. For the next example, again, start with your proportion with a fraction on either side of an equal sign. Insert the extremes, 4 and 16. Put a variable in to represent the values we don't know. Cross multiply. And you would have y squared equals 64. The opposite of a square is a square root. Y equals 8. One last example. We would, again, start with our equal sign with a fraction bar on either side. Put in our extremes. Put a variable in to represent the means. Z squared equals 77. The opposite of a square is a square root. 77 is a prime number, so your answer is square root of 77, which you could take to decimal form. Now let's try an example where we have the large right triangle with its altitude, and we see our small triangle here, our medium triangle here, and our largest one following the perimeter of the shape they started with. Let's transfer our values to these representations of small, medium, and large triangles. So for the smallest one, it has the hypotenuse is x, and the small leg is 3. For the largest triangle, we have a y on the back, we have an x on the base, and we have 9 plus 3 is 12 for the hypotenuse. And for the middle-sized triangle, we have the hypotenuse is y, and the back side is 9. So for our x's, we're going to have to use our small triangle and our large triangle, and we'll be using the base and the hypotenuse, the base, and the hypotenuse, just like we learned to do in our similarity unit. Start with a proportion, put in our extremes of 3 and 12, put in our x, we cross multiply, we get x squared equals 36, so x equals 6. So there's a 6 right there. That was the base of the large triangle, so we can insert that here. Now to solve for y, it is the hypotenuse of our middle-sized, and we do know our hypotenuse of our large, and we also have our middle-sized leg of both those triangles. So for our next solution, we will say equal sign, fraction bar on either side, y is going to be our means, and our extremes are our 9 and our 12. When we cross multiply, we will get y squared equals 108. Take the square root of both sides, and then y will equal 10.3923 for decimal answer, or if we do our 108 to get it to simple radical form, dividing in with prime numbers, right? 2 goes to 108 gives me 54. 2 goes into 54 gives me 27. 3 goes into 27 gives me 9. 3 goes into 9 gives me 3. And 3 goes into 3 gives me 1. For every pair, one number comes out from underneath the radical. But anything that's alone does have to stay under the radical. And then we multiply and end up with 6 square roots of 3. If you put 6 square roots of 3 in your calculator, it will be 10.3923. There's examples of geometric mean practice problems.